Thank you very much. I'm really excited to be able to present my topic here today. So, my name is Antoine. I work at Switch, which is the National Research and Education Network of Switzerland, but I'll tell you a bit more of Switch right afterward. Here's the agenda. So, intro to Switch. I want to give you a super fast intro to blockchain, proof of work, and cryptocurrencies, so that you can understand why this is even a problem, web crypto mining. Then, well, we'll get to the topic of mining in the browser with JavaScript. And then, since Switch is also the .ch registry, we have an overview of all the .ch domains. So I did a little research on all websites running on .ch and who is affected by a web crypto miner. And in the end, I want to show you or tell you about what Switch is doing about that. So for the first part, the introduction to Switch. Switch is a foundation which was created about 30 years ago and is closely related to the history of the internet in Switzerland. So in May 1987, Professor Plattner submitted a request to IANA to kind of register the .ch TLD, which he did by sending an email, and they told him, well, yeah, here you are, we registered .ch. They actually just put .ch in a zone file. And shortly after, in October 1987, the foundation was created, and he was the managing director. So he handed over the .ch to the foundation. This is here. Why was Switch created? Here's an excerpt from the Deed of Foundation in October 1987. So the objective of the foundation is to promote modern methods of telecomputing, which is a pretty old-fashioned word, but for the 80s, it's okay. We'd say maybe IT nowadays. So promote telecomputing teaching and research in Switzerland. So the idea was, you have nowadays we have about 68 universities at different levels. So you have the Federal Institutes of Technology, you have the universities on the canton level, then you have universities of applied sciences, you have some private universities, and so on. And all of these organizations had the same requirements to be able to exchange data between one another. And instead of doing that all by themselves, they decided, with the support of the federation, to pool resources together and to create Switch, which is the goal of the foundation. It's a non-profit foundation, and we don't have any profit strategies, which is kind of nice for a change when working at Switch. Okay, so back in the timeline, when 2 years later, the Switch LAN was created. And what is Switch LAN? It's actually the backbone, and it was the first IP-based backbone in Switzerland. This is the map of the backbone nowadays. If you look back in history, the first link was between the two institutes of technology, one in Zurich and the other one in Lausanne, with a speed of 128 kilobits per second. Nowadays, we have 100 gigabit routers. And you see, we try to have most of the path in a redundant way so that every organization has a good connection to internally between one another, but also to other networks like Géant, which is also the research and education network on European level, and also commercial ISPs, and so on. Okay, so this was actually the first version of the internet in Switzerland. Then in 1990, Switch becomes the registry for .ch. So with the internet, when you have IP, you also need to resolve domain names, because otherwise it's kind of like a pain if you need to remember all those IP addresses. So it was pretty naheliegend, pretty evident that Switch would also operate the DNS infrastructure for the developing internet at the time. Then, during the early 90s, we noticed that network security is an issue. So on an international level, the first CERT organizations, so computer emergency response teams, were created. And I think Switch started a team already in 1992, but in 1996 it got its CERT certification, and from then on Switch has been really involved in matters of incident response for the network, for the university network, but also for other network operators in Switzerland. And it was actually the first CERT in Switzerland. Next, in 2002, the operation of the .ch went in the responsibility of the Office of Communication. So the Federation said, okay, this internet thing is getting bigger and bigger. I think we need to regulate that. So they took responsibility of .ch, but mandated Switch to still operate the registry. And in 2010, we had the Ordinance on Internet Domains, which is relevant for fighting cybercrime, which tells you how to deal with domains, and then later on how to fight cybercrime. Okay, the last slide on the introduction. Who are our customers? So, primarily the Swiss universities in the academic sector and other research institutions. Then you have an extended community of organizations which are also involved in research and education, like research facilities, libraries, and so on. But we also serve commercial customers. So on the registry level, we have actually anyone who has a .ch or .li domain is indirectly customer of us, but our primary point of contact are the registrars. Then you have Swiss financial institutions, to which we also offer CERT services, and everybody in the research-related industry and government areas. Okay, so let's go on with the intro to blockchain and cryptocurrency and so on. Why do we even need a blockchain? Because it's pretty hip, and if you read like IT news, it seems that blockchain is the solution for every problem. But what problem are we really wanting to solve with the blockchain is you want to have a decentralized database with entries and data that we can all agree on. So we want to have a consensus on the content of the database, and we want to make sure that nobody can change those contents afterwards and manipulate them. So how is this done? So obviously I had to draw a blockchain, and if we have all those blocks that are chained together, and I want to add a new one, so let's look at block number 17. So you'll have the payload, the data. And in the special case of cryptocurrencies, you're going to have transactions. So if we look at the transactions, we have Eve gives $100 to Katja, $35 from Andreas to Daniel, and then Dobin is very nice. He gives me $1,850,480. Thanks, Dobin. Where are you? And this is what Dobin would like to prevent. He sees that's obviously not him that did that, so he wants to prevent anybody of inserting a rogue transaction. So how is the chaining done is when you take the blocks, you're going to represent them as hashes. And the red arrows on the slide are represented by the hash of the previous blocks. You're going to refer to the previous block, so the new block will base upon the previous block. And if you assume that block number 17 is the correct block, then if you go back in the chain, then you can make sure that all other blocks, also the whole integrity is valid. Next, what you also have in a block is a random number called a nonce, which we'll see just afterward why it is used. But then you have the hash of the actual block, and the hash of the actual block will protect the block and is actually pretty difficult to compute, but very easy to validate. So all consumers of the blockchain, they can very quickly figure out, okay, this block is good because the hash corresponds to the content of the block, and you can do that recursively with every previous block. But actually to come up with this hash is rather a hard task, and you want to give an incentive to people to mine the block to find the right hash to do it, because you're going to give them a reward in the corresponding cryptocurrency. So to understand how mining is done, we first need to talk about cryptographic hash functions. So say you have a string and you want to hash it. You're going to put it through a hash function like SHA-1, which is maybe not the most secure one, but it's just for the example. What you get as an output is a string or a binary blob of a fixed length, in this case 160 bits. But you could have applied exactly the same function on any data of any size. So here, for instance, the Blu-ray disc of hackers, you would get this hash, which differs from the first one because it's not the same input. And if I were to change only one bit in the Blu-ray disc, the hash would look entirely different. It would look like totally randomly different. So the idea for an attacker is to find an input X that would actually match to the same output as the hacker's Blu-ray disc. And this should be computationally infeasible. But what we're using in the blockchain is exactly this property, that we want to have a specific hash as a result, but not a specific hash in itself, but a specific property of the hash. So actually, what we're asking the miners to do is to come up with a hash that will have a certain prefix of zeros, and the rest, the green part, is whatever you want. So this is how you model the difficulty in the mining part. And the difficulty can adapt over time because you require then to have more zeros at the beginning. So if you start with a very easy mining algorithm where you say, okay, the first zero of your hash should be the first bit of your hash should be a 0, then you have a 50-50 chance to satisfy this requirement. But if you say you want to have the first 90 bits of the hash, all of zeros, then it gets exponentially harder. So now let's get back to the nonce I mentioned previously. You can think of it as a lottery ticket, but unlike the real lottery, you don't need to buy tickets. You can have as many as you want. You just need to choose a nonce randomly. And actually the lottery numbers are chosen, you have a time window of about 2 to 10 minutes, depending on the crypto system, the blockchain system. And you need to find a nonce which will satisfy the requirement of the number of zeros in the prefix of the resulting hash, like this. And the first person to come up with a result gets the reward and can insert a new block in the blockchain, and everybody validates it, that the block propagates, and everybody accepts this as a new block in the blockchain. So obviously, not everyone can do that just like that. You need to have certain competition. And the competition is done with computing power. If you look at the beginning of Bitcoin, you could very easily get rich and by only using the CPU in your laptop. But then with time, because of the properties of the Bitcoin blockchain algorithm or proof of work algorithm, people started to think, okay, I have a gaming machine, I have a graphics card in it, and the graphics card is really good to do parallel processing. So this SHA-256 algorithm, I can parallelize that and compute a lot of different nonces in parallel, and I'll be way more faster than all of my competitors. So that was around 2010 when this came up. Then people started to say, okay, how can we specialize even more? So let's take an FPGA, program the hashing algorithm within an FPGA, which gets more and more specialized. And the current state of the art is having application-specific integrated circuits to do your mining. But you're not only going to have one of these. If you want to play the game with Bitcoin, what you need actually is a whole farm of those ASICs. So that's problematic, because what you want to achieve in a blockchain system is this diversity. So you want to make the system fair so that nobody has a control over the blockchain. Now, nowadays, only a few entities can afford to have such a setup. So like mining pools, or maybe, I don't know, maybe state actors, could be. And it's not decentralized anymore. So you have maybe a couple of entities, like 3 or 4 entities, that if they put themselves together, they could have a really big impact on the blockchain, and they could have more than 51% of the participation in the blockchain. So that means they actually decide which block gets put into the blockchain, which not. So this is why in the evolution of blockchain, you have different alternative systems, and one of them is Monero, which tries to defeat the this evolution where you can get very specific hardware and a specialized hardware to do the mining. They want to make crypto fair again, so that everybody, like me with my laptop, I can again play the game and mine and earn something, because then it's much more difficult for someone to take control of the blockchain. Monero, in addition, designed some privacy aspects, well, a lot of privacy aspects actually, and unlike Bitcoin, it's very difficult to track the transactions. So there are a lot of websites on the internet where, like blockchain.info, where you can track all the transactions. If you have a Bitcoin address, you can see where the whole money flows and so on. So people need different addresses to make sure that nobody can link their activities. With Monero, it's not the case. It's almost impossible to figure out one origin address, starting from one address in the origin, what transactions were made. Okay, so this makes Monero very interesting for hackers as well. So we saw yesterday's talk from Dave Liebenberg. He talked about Monero bots, how they were deployed and so on. And with the vulnerabilities like Drupalgeddon, it's now the new thing to do. When you have remote code execution, you can automatically install your miner. It's very maintenance free. You just drop it and configure the right target address, and then leave it and go and hack the next one. So I think yesterday or on Thursday, there were also reports of Docker instances, which you could get from Docker Hub, which were compromised. So anybody who would retrieve those Dockers would already have a miner in it. And so I think the evolution is hackers are trying to put Monero miners everywhere. We had a case, a very interesting case of a client who unfortunately left the Docker management interface open. It's somewhere on a high port. It's not a standard port, but if you look at the Docker documentation, they give you an example of the port. It's in the 4,000 something. And actually, the port by itself is not authenticated, so you need to block it, to block the access from the internet. There was exposed, and I think they were a victim of automated attack, which would just scan the whole internet and see where they could find any exposed Docker interfaces, and then inject a new or create a new Docker container which has a miner in it. Okay, so let's also look at the algorithm comparison. The reason why Monero is possible to mine on general purpose computing devices is because it's not only CPU bound. So with Bitcoin, you need to do SHA-256 computations twice in a row, and you can parallelize this. And for Monero, what you need is a CPU, obviously, but also a lot of memory, because in the algorithm, what you need to do is build up a scratch pad of 2 megabytes. This means it's like your working buffer to then do the hash computations on it. So what's good hardware to do it is CPUs with large caches on it. So if you have a L2 cache of 2 megabytes, then you could fit in the whole scratch pad, and you can work much more efficiently. Okay, so let's go on to mining in the browser with JavaScript. So I guess a lot of you have heard about CoinHive. It's a service that started about a year ago, well, in July 2017. And they offer a JavaScript miner for the Monero blockchain, which you could use and insert into your browser and mine. Well, actually, it's the visitors of your website who are going to mine for you, for the operator of the website. And they advertise the service as an alternative to advertisements, which is great because I hate ads. On the other side, you need to figure out how to do it the right way so that your visitors know, okay, I'm currently mining for the website operator. We'll get to that later. So how does it work technically? You need to bind the external CoinHive miner script, and then you instantiate the miner with your address. If you want to see an example of that, you can go on coinhive.ch, which I registered, and you can see how that works. And if you have the website open, just leave it open a couple of hours, days. Okay, so what happens when you download coinhive.min.js? You'll get a JavaScript file which will then check if your browser supports WebAssembly. If it doesn't, it will load an asm.js version of the miner, which is actually a subset of JavaScript which works very efficiently, which is optimized for, well, I mean, I have no idea of how JavaScript is executed in a browser, but I know that some parts are compiled just in time, and I think the motivation behind ASM.js is to make it as efficient as possible by knowing how the stuff is just in time compiled. On the other hand, WebAssembly is actually bytecode that you can compile like a normal binary executable, and you load it to the browser, and you should have some more efficiency. But from what I've seen, I tried both versions. I get actually about the same hash rate. So it's neat that you have the different implementations, but I think in the end it's not that relevant for the computed hash rate. And I think the hackers don't mind either which version you're going to download. So I did a little test with different devices. The first row is my Apple A7, that's the processor in my iPhone, and with 2 cores with 512K of L2 cache each, and I can achieve 16 hashes per second with that. Then in the office we all have Macs, so we have Intel Core i7 processors, different frequencies depending on how old the laptop was. Always about the same amount of caches on different cores. And as you can see, the fastest machine, which, well, in the last row, which wasn't an Apple PC, but was like 60 hashes per second. That's mining in the JavaScript. If you have a native miner, like the ones you would get installed from a bot, a mining bot, you could achieve up to maybe 100 or 200. Also, if you leverage the GPU that modern laptops have, then you can also, say go up to 200 hashes per second. But now, for the next computations, I would say an average laptop you should achieve about 50 hashes per second. So a small revenue calculation. If you go on CoinHive, at the day I made the slide, they would give you really a little fraction of XMR, which is the abbreviation for Monero, per 1 million hashes. So whenever your visitors mine 1 million hashes, you would get that fraction of an XMR. And the conversion rate is 1 XMR is $188. So if you do that on one system during 1 hour at a rate of 50 hashes per second, and you generate during that 1 hour, you don't generate 1 million hashes, but a fraction of 1 million hashes, like 180,000 hashes, then you get nothing. If you want to get close to somewhere to have some revenue, you can scale it up and say you have 100 visitors during 1 hour on your website mining at 50 hashes per second. Then obviously it's 100 times more hashes generated, so 18 million. You get still almost nothing. What you really need as a computing power to get like a dime is 10,000 systems during 1 hour at the same hash rate. And say you want to have the same in a 5-minute window, then you'd need 120,000. But that's not all, because CoinHive is taking a 30% pool fee. So yeah, they're making a lot of money actually from everyone. I mean, 30% is really a lot. But I mean, their system is really easy to use. So you just need to put the script in it with your address, and it works. I don't know if that legitimizes that mining fee, but okay, it's not a problem. Okay, so next, I wanted to figure out how bad does this look like in the Swiss websites community. So what I did is, obviously, as a registry, we have access to all .ch domains. I took those, these are about 2 million domain names, and took the file, put that in a Redis queue. On the right of that Redis queue, you have OpenShift with a little cluster of Docker instances which run Scrapy, which is a very nice Python project used to scrape websites. But in this case, I didn't want to scrape I just needed the whole HTML file. So what I do is I go on the website using the domain name. I just put http:// in front of it with the domain name, and try to resolve that and to access the HTML file. If that doesn't work, I also try to put www in front of it, dot, and then do it. And if this still doesn't work, well, I don't store anything. For the websites that are accessible, I then take the HTML content just of the front page, of the homepage of the site, and put it in Elasticsearch, where I can then search for patterns. The thing is, I'm not indexing all of the websites in .ch because I don't get all the subdomains. So if you look at, for instance, institutes in universities, you have a lot of subdomains. I don't get them. I just get the principal domain. So who's mining on your back? I did 3 samples, and one of them in January. So you see, there's not really much people having miners. The first one in January 90, then 15 more in April, and then almost 11 more in May. Always using the same patterns. Okay, I always took the fresh zone file. There are TLDs who offer the whole zone file as open data, so you can access all the .fr domains, the .sc as well, and you see that, well, it's very marginal, the number of crypto miners you have on them. I guess if you would go on .com, it would look differently, but I didn't access that. So then I thought, okay, let's have a look at the affected CMS systems in Switzerland. So you see there are a lot of WordPress, like a third of it is WordPress, then you have a lot of Drupal, small, I think Drupal was more, but it wasn't, and then you have Joomla, but it depends also on the market share, of course. Then I thought, let's have a closer look at the WordPress instances, and to see, here on the left side of the pie, you see most of them were on the actual current version of WordPress. And I guess it doesn't only depend on the version number of WordPress, but also on all the plugins you have on them. If you look at the different addresses which were injected in the code, you see some of them were used as many as 14 times. So, and looking at the websites, they had no relation to each other. So this is an indicator that they got hacked. I also took one of these addresses, and I didn't know, I learned that a couple of weeks ago, you can do HTML content search with Shodan. You need to be logged in. And then this address produced like more than 500 hits for the same address. So obviously this was a hacked case. So why are people crypto mining? Well, the legitimate case is the operator mines and with the user's consent, but then in the second case, the miner originates from the operator, but he doesn't communicate it. And the third one is the site has been compromised and a crypto miner was injected. So here's an example of the legitimate case. It's a website called Ad-Free TV where you have video streaming, which makes a lot of sense because while you're watching your 2 hours movie, in the background, it's streaming. If you go in the About section, they say we're using a miner while you're using, so I think it's pretty fair. It's made evident. But in the meantime, the website is still online, but they don't use the miner anymore. I don't know why. Then the second example is obviously a hacked website because you see the miner script is injected 3 times in a row, which doesn't make any sense. So this was probably a HTML injection. With time, there came a lot of browser add-ons which would block crypto miners. Also, your conventional ad blocker like uBlock or something, they would detect also the existence of miners. So what do the hackers do? They obfuscate the code. This is what it looks like. Then also have the example for somebody who is intentionally mining. I guess so because this website is about Bitcoins and cryptocurrencies. He has a miner on it, but he doesn't tell it. It just so what I do is I go away, but I mean, he doesn't even have a valid certificate. So, okay, I got to go a bit faster. What's Switch doing about it? Nothing, no. So I already said we're mandated by the Office of Communication to operate the registry, and as part of this mandate, we also need to keep the .ch zone clean. That means if we see instances of phishing and malware, we need to get in contact with the operator of the website, the domain holder, the registrar, and the hoster, and we give them 24 hours to clean up the malware, the phishing. And if we don't get anything, any reaction, then we take away the domain from the zone file. Within 2 or 3 hours, nobody is going to be able to resolve the domain. So, if we look, one more thing. We asked the Ofcom how to handle Cryptominers. Is it malware or not? Their answer was, it is malware. So, every time we see a crypto miner, we should get in contact and launch the process and eventually maybe block the website. How are we actually dealing with it? So if the operator places a secret crypto miner, we're going to inform him and tell it it's not right. If a website has been compromised because it was hacked, we're also going to inform and eventually block. But we leave one thing open as a legitimate case. If somebody informs the visitors he's using a crypto miner, then it's okay. But how do you ask the visitors for the consent? In the example before I showed you, you need to go in the About section and you see, oh, okay, the operator tells me he's mining, but that's not really obvious. My suggestion would be to use something like the cookie consent you see on all European websites, where you say, oh, I have to accept the cookies. And fun fact, when you say you don't want to have cookies, the websites place a cookie to remember that you don't want cookies. But that's another story. I just took one of those banners and just changed it like for using it for crypto mining. So that could be something people would want to do if we see that crypto mining as is a real alternative for advertisements. Okay, I want to end the presentation with a very interesting case. So for the case of these cookie consent banners, you could use JavaScript. So this is a website who offers such a JavaScript. It's called CookieScript Info. So you don't have to code it yourself. But if you go and have a look at some of their JavaScript versions in the past, which are deployed on content delivery networks, well, you see their JavaScript is injected, and well, so somebody is making big money with them. Okay, that's it. Thanks for your attention, and I'm open for questions if we still have some time. Good, thanks.
Awesome. Thank you very much. That was very, very informative and interesting. Does anyone have any questions at all? We still have a few minutes before we move on to the next one. So please don't be shy. Beautiful.
Thank you. When you inform the holders, how many are saying, oh, actually, it was not intended, or how many are saying, oh, but I'm fully in the right of putting a crypto miner? What is the percentage?
The website I showed the example with the video streaming was the only website where I noticed somebody's doing it with the intent of like using web crypto mining as an alternative to advertisements. So all other people, all that we contacted, they were all like, oh no, I wasn't aware there's a crypto miner on my website and I'm going to clean it.
Any other questions? Anyone? You're making this too easy for him. No? Okay, cool.
Okay, thanks a lot.
Thank you very much. Yeah, please. Thank you again.